is from 1335. The text reads, the coefficient of the static friction between the 200 kilogram crate and the flat bed of the truck is mu sub s equals 0.3. Determine the shortest time for the truck to reach a speed of 60 kilometers an hour, starting from rest with constant acceleration so that the crate does not slip. So I went ahead and wrote down the given and the find. And we want to find the shortest time for the truck to reach that velocity of 60 kilometers an hour, starting from rest with constant speed. And we want to make sure the crate doesn't slip. So conceptually, just look at the problem. So what we really need to find first is what acceleration, what horizontal acceleration happens before slipping happens. So I'm just going to start with a free body diagram and a kinetic diagram of the crate. So free body diagram. So we have the weight of the crate, which that equals mg. So it's going to equal 200 kilograms times 9.81 meters per second squared. We're going to have a normal force. And then if it starts moving, the crate will move back, so that force of friction that's holding it on is going to be in this direction. And then we have the kinetic diagram. So draw the crate again. And for the kinetic diagram, we have the center of gravity, so G, and with that, we're going to have, we'll have acceleration, some a sub x. We don't have any acceleration in the y direction. We don't have any rotational stuff going on. So if we can sum the forces in the y direction, it's just going to equal 0. And so with that, we have that negative w plus n equals 0. So n is going to equal w, which equals that 200 kilograms times 9.81 meters per second. So that's 1962 newtons. So that's the weight. And that's the weight and the end force. If we sum the forces in the x direction equals max. I guess we should have said that we'll do positive x to the right and y up. So sum of the forces in the x's, x equals max. We get negative force of friction equals max. And the force of friction is going to equal negative, and that we had that mu sub s is 0.3. Let's just write that there. So mu sub s times n equals max. So ax is going to equal negative mu sub s is the 0.3 times n, which is at 1962 newtons, divided by the mass of the crate, which was the 200 kilograms. So we get acceleration equals negative 2.943. And newtons is kilograms times meter per second squared divided by kilograms. So it's meters per second squared. And it being a negative just means that it's actually decreasing, or it's actually going to the left. So acceleration x equals 2.943 meters per second squared. It's actually going to the left. So we can get to that acceleration without it slipping. And so we can, so now we know what that constant acceleration is going to equal. And we can go ahead and pull up some of those equations that we know. So velocity, when we have constant acceleration, the velocity final equals, velocity final equals velocity initial plus the constant acceleration times time. The final velocity is going to be that 60 kilometers per hour. And that equals, and it started at rest, and then plus that 2.943 meters per second squared times time. So we have a little bit of a problem. We have meters per second and kilometers an hour. So we'll just change this into meters. So 1 kilometer is 1,000 meters. So that'll cancel out that kilometer. And then for hours, 1 hour is 3,600 seconds, 60 minutes, and 60 seconds in each minute. And so we get time equal to, let's see, so if we multiply this out, we get 16.6 repeating, and that's hours cancel out, so that's meters per second. That equals time, and then we divided that by the 2.943 meters per second squared. So the meters cancel out. One of the seconds cancel out, so we just get seconds, so that unit is right. 16.666 divided by 2.943, and that gives us 5.66 seconds. So the shortest time for the truck to reach 60 kilometers an hour starting from rest with constant acceleration so the crate doesn't slip. And so that was what we found here.